Okay, so for FRQ number 6, for the first half, we have a 0.25 kilogram light fixture in an elevator. We are hanging it using two 80 centimeter wires, and they are going to be fastened to hooks that are 1 meter apart. So part A wants us to find the tension of the two wires. So first off, I'm going to draw a diagram of what the problem. So here's our two wires. So here's the light fixture. They are 1 meter apart as the problem said, and the length of them is 80 centimeters, which is 0.8 meters. 0.8 meters. And so since it's asking for tension, I know I'm gonna be dealing with forces. So I'm gonna draw my forces on the light fixture. So I got FG for the light fixture right here. And I got these tensions. Now I know tensions have two arrows, but I'm gonna point it just this way because I'm only focusing on the light fixture. Okay, so I know that my FG would be equal to my the addition of my T the Y component of my TYs. So that's gonna be an important relationship, but to find my TYs, I need to know these angles. This angle, these two angles are here, which are the same because the wires are the same length. So to find these angles, I'm gonna use what is called the cosine rule. Cosine rule. And the cosine rule is this: a squared plus is equal to b squared plus c squared minus 2 b c times cosine of theta. So essentially what the cosine rule is that we can use it to find any angle if we are of a triangle if we have the given lengths of each side. So I'm gonna isolate for theta. Isolating for theta, my let's see, if I isolate for theta, I'm going to subtract these two right here. So a squared minus b squared minus c squared. And then I'm going to divide by negative b 2bc. Negative 2bc. And then I still have cosine left, so I'm going to have to take the arc cosine of this whole thing. So cosine of this whole thing. And that should, okay. So at this point, I can use this to find my thetas. So first of all, I'm gonna so a square. My a has to be the length of a segment that is of the side that's opposite to the angle. So if I'm solving this angle, which I'm gonna do, this is gonna be, so my a is gonna be 0.8 meters. B and C can be either side, so let's just do B is equal 0.8 meters, which is this side, and C be this part right here, 1 meter. So now, just plugging in my numbers in, theta is equal to cosine of -1, 0.8 meters squared minus 0.8 meters squared minus 1 meter squared divided by -2 0.8 meters times 1 meter. Plugging this into the equation, my angle turns out to be 51.318 degrees. So both of these angles will be 51.318 degrees. So now that we have that, we can use that to find our tensions. So an important equation to use is Newton's, of course. So the total force is equal to mass times acceleration. In this case, I'm going to be looking in the vertical direction, so the total force in the y direction is equal to my mass times acceleration in the y direction. Okay, now I do not have acceleration in the y direction because this is stationary, so this term is going to cancel out. So what I'm going to have is my total force is going to be I have two ty's pointing up right here. So ty and ty. Ty plus ty, and then I have fg opposing it, minus fg, and that's going to equal 0. So this leads to my statement, as I said before, my two ty's combined is going to be equal to my fg. Ty on the side is I'm going to define as equal to t sine of theta, and theta I found, so t sine of 51.318, and that is going to be equal to 0.7806 t. So this is basically allows me to define ty in terms of t, which is what I'm trying to find right here. So I'm going to plug this in to the original equation. So 2 times ty, substitute, is 0.7806 t. My fg is mg. Times this is 1.5612 t, and then my mass is 0.25 kilograms. My gravity is 9.8 meters per second squared. So we want to solve for t, so we just divide this over, and we have t. So t is equal to 0.25 times 9.8, and divide this 1.5612, and our answer turns out to be 1.569 newtons. So this is the tension of both wires if the light fixture is stationary and the elevator is not moving. Okay, so part B, we are asked to find what the new tension is if the elevator is starting to accelerate upward. Okay, so again, we're going to use Newton's. Delta, or total force, is going to be equal to mass times acceleration in the y direction, of course. Same forces we have up here, so ty plus ty minus fg. But this time, this side is not going to be 0. We actually have an acceleration. If the elevator is moving at 1 meters per second upward, the light fixture will do the same, so it will also have a acceleration of 1 meters per second squared upward. So ma. So this turns out to be 2 ty combined minus fg is equal to ma. Now I'm gonna plug in my numbers. 2 ty we define up here. It's up right here. So 0.7806 t minus fg we've also found up here, 0.25 kilograms times 9.8 meters per second squared. And that's going to be equal to mass is 0.25 kilograms. 25, sorry. 0.25 kilograms, and acceleration is 1 meters per second square. Okay, so this reduces down to 1.5612 t. This reduces down to 2.45, and this reduces down to 0.25. So if we want to solve for t, we're going to add this over, divide by 1.5612, and we should get t. So this, add this over, then divide by this term over here, 1.5612, and plugging this in the calculator, we get 1.729 newtons as our new tension. Okay, the second part of number 6, we have the same light fixture with a mass of 0.25 kilograms, but then this time we have 4 wires instead, and they are each fixed at a corner of a 1 meter by 1 meter square. So again, we're going to draw this out and use it to find our tensions by finding our angle. So see, this is a top view of the wires. So let's say this is a top. The wires are all 1 meter apart, so 1 meter, 1 meter, and so the end is going to be right here, pointing to the middle, to the middle, to the middle. Okay. So this is a 45-degree angle right here, and then we divide. What we want to find is this length right here for the top. So it's going to be, so this length is half of this is going to be 1/2 m, 1/2 meter. And if we want to find this length right here, L, basically it's going to be equal to, so sine of 45 is going to be equal to, so opposite is 0.5 and L. And then, so if we want to solve for L, multiply L over, divide by sine 45 to the side. So L is going to be equal to 0.5 divided by sine 45. And we get 0.707 meters for L. This is the distance on top, not the actual distance of the wire. So now this is the side view of one wire. So this is the wire we found to be 0.8 meters, or it was given to be 0.8 meters. And what we just found up here is actually this length up here. So this is L, and it's going to be 0.707 meters. And so now that we have this, we can find our angle. Okay. So we can use cosine to find our angle. So cosine of angle of theta is equal to adjacent is L, so 0.707 meters, and hypotenuse is 0.8 meters. We want to find theta, so we take an arc cosine. So angle is equal to arc cosine of this whole thing. And plugging this into a calculator, we get 27.902 as our angle right here. Okay, so now that we have that, we can set up newtons to solve for our tensions. So again, same equation, total force is equal to mass times acceleration in the y direction. Now Now this time we have 4 wires, so we're gonna have 4 ty. So ty plus ty plus ty plus ty, and the opposing force is gonna be Fg. So basically, this is what ty is, and there's Fg down here, and there's 4 of these 4 wires. This is Fg. Okay, and again, for the first part, our acceleration is going to be 0. So go 0. And so this turns out to be 4 ty, and then subtract add Fg over. So 4 ty is going to equal to Fg. Now I have to define my ty to the side. My ty in terms of t is going to be equal to t sine theta, and that's going to be equal to t sine of the angle right here, 27.902. And so plugging into the calculator, we get 0.4680 t. That is our ty in terms of t. So now I can plug this in. So 4 times 0.4680 t, and Fg is mg. So 4 times this thing is 1.872 t. I'm gonna plug in my mass and g. My mass is 0.25 kilograms once again, and g is 9.8 meters per second squared. Isolating for t, we just have to divide this over. So t is equal to 0.25 times 9.8 divided by 1.872, and that gets us 1.309 newtons. So that is the tension of each wire. So part D asks the same scenario as part B, but this time with 4 wires. The elevator starts accelerating upward at 1 meters per second squared. What is the new tension of each wire? So same thing we're gonna do as B. We're gonna set up newtons again, but then this time with the acceleration existing. So I'm gonna do this on the back side. Part D. So we have newtons once again. Total force is in the y direction. It's going to be mass times acceleration in the y direction. Once our total forces are ty plus ty plus ty plus ty minus Fg, and that's equal to MAY. This reduces down to 4ty minus Fg is equal to MA y. And so right now I can just plug in my numbers. So ty I define back here is 0.4680 t. 0.4680 t minus Fg is 0.25 kilograms times 9.8 meters per second squared, and then mass is 0.25 kilograms. Acceleration is 1 times 1 meters per second squared. Sorry, I'm getting out of space. So this term reduces down to 1.872 t. This term right here reduces down to 2.45, and this mass over here is just basically this is 0.25 times 1, so 0.25. So isolating for t, we just have to add this over and divide by this right here. So T is equal to 0.25 plus 2.45 divided by 1.872. Plugging this in a calculator, we get 1.442 newtons. So that is our tension of each wire as the elevator is accelerating upward at 1 meters per second.